Hello everyone. So in today's class, we are going to learn analytical treatment of interference. So yesterday I told you what is interference, then what is constructive interference, what is destructive interference. Yes. So in today's class, we will learn analytical treatment of interference. So let's see here. Now I am having one source, that is monochromatic source I am taking. Like this. And now here I'm taking here will be your screen. Here it will be two slits, we can see like this. These are the two slits, and now this is the displacement of the first wave will reach here, and this is the displacement of another wave like this. Okay. So this is what? This is a source. Yes. And let us suppose this slit is slit A, this one is slit B, and the distance between these two slits is, let us suppose, small d. How much is the distance? Small d. And this point is point. And I'm giving this point name as a point C. This one is point C. This distance is capital D. Distance between slit and screen. How much it is? Capital D. Okay, this is capital D. Now let's start. Now let us suppose displacement of first wave is y1. Y1 is equal to a naught sine omega t, and y2 is equal to a naught sine omega t plus phi. Okay. Now, according to the principle of superposition of wave, already we have learned, right? So what is according to, or what is the principle of superposition wave? Resultant displacement is equal to y1 plus y2. So according to superposition principle, of wave, y, that is resultant displacement, is equal to y1 plus y2. Now just substitute the values of y1 and y2. So therefore y is equal to A0 sine omega t, at the place of y1 I have substituted, plus this is y2, A0 sine omega t plus phi. Okay, right? Now this term I am keeping as it is, A0 sine omega t plus this is A0, and this is sin A plus B formula, sin A cos B, cos A sin B, you know. So therefore what you will get here, direct I am writing A0 sine omega t cos phi plus A0 cos omega t into sin phi. Any doubt? A0 cos omega t into sin phi. Why I wrote this? Because we know sin of A plus B is equal to sin A cos B, sin A cos B plus cos A sin B. You know this formula, you can use it. Okay, right. So what we got, y now, A0 sin omega t plus A0 sin omega t cos phi plus A0 cos omega t sin phi. So if I will take A0 sin omega t common from these two terms, what I am taking common, A0 sin omega t common I am taking. So what is the next term? Sin omega t common. What is left here? This is 1 plus what is left here? Cos of phi plus this term as it is, A0 cos omega t into sin of phi. This is what your y is. Okay. Now we will do substitution. What is that substitution? See, this term is there, no, 1 plus cos phi, and here A0 sin phi is there, no, this and this, even this also. Okay, A0. So A0 into this we will keep as a r cos theta, and A0 sin phi we will keep as a r sin of theta. Okay, so see here, now let's substitute. Put A0 into 1 plus cos phi as r cos theta, call this as equation number 1, and A0 sin phi is equal to r sin of theta, call this equation as equation number 2, right? So what we are getting, y now, y is equal to A0 1 plus cos phi, क्या होगा, r cos theta, so r sin omega t, r sin omega t into cos of theta plus r cos omega t into sin of theta, right? And if again we will see here, we are getting one form, so therefore y is equal to again r sin omega t plus theta. Yes. Now this is your equation number 1, 2, and this one is your equation number 3. Keep it in a box. Same formula we have used. Which formula? sin a plus b, है ना? Sin a plus b is equal to sin a cos b, cos a sin b. Yes, this one. And this is your equation number 1, and this is your equation number 2. So you got 3 equations now, 1, 2 and 3. So keep it in a box, note down properly. Why we are doing this? Because we want to get, or we will get from this, intensity and amplitude relation. Okay, that's why we are doing this. Let's move ahead. Now, what is our equation 1? We got like this: a0 into 1 plus cos of phi. This is your equation number 1, which is equal to r cos theta. Equal to r cos theta. Yes, your equation number 1. And another equation is what? A0 sin phi is equal to r sin theta. This is your equation number 2. So what we will do now? Squaring and adding equation 1 and 2. Squaring and adding equation 2 and 1. 1 and 2 or 2 and whatever it is. So see here, r square sin square theta plus r square cos square theta is equal to r square sin square theta is what here? A0 square sin square phi plus a0 square into bracket 1 plus cos phi whole square. Yes. So if I will take r square common here, if I will take r square common, what is left in the bracket? Sin square theta plus cos square theta. And this is equal to here a0 square sin square phi plus this is a0 square. First I will expand this a plus b whole square. This is 1 square is 1 plus 2 into 1 into cos phi plus cos square phi. Yes. So this is going to be 1. So this is just equal to r square because this is 1. Sin square theta plus cos theta is 1. So here you are getting a0 sin square phi plus multiply this a0 square with this whole bracket. So this is a0 square plus 2a0 square cos phi plus a0 square cos square phi. Now again you are getting two terms in which a0 square we can take common, these two terms. So if I will take common from that, then again I will get r square is equal to, direct shall I write? A0 square common sin square phi plus cos square phi plus here it is a0 square plus this is 2a0 square cos of phi. Right? Now this is going to be 1. So you are getting a0 square plus a0 square plus 2a0 square cos of phi. This is your r square and therefore r square is equal to 2a0 square plus 2a0 square into cos of phi. Okay, now r square is equal to, if I am taking 2a0 square common, what is left? 1 plus cos of phi. 1 plus cos of phi. Now here if I will use formula, half angle formula particularly, cos of phi is equal to 2 cos square phi by 2 minus 1. Yes, that is what your cos phi. So let's substitute here what we are getting then. This is equal to 2a0 square into bracket 1 plus 2 cos square phi by 2 minus 1. So this minus 1 and this plus 1 will get cancelled. Now what is left here? 4a naught square. This 2a naught square into 2. 4a naught square cos square phi by 2. This is what your r square. And therefore r is equal to, if we will take square root of this is 2a naught cos of phi by 2, right? This is what your resultant amplitude. What is this? Resultant amplitude. Now we got r value, so substituting in equation, therefore equation 3 becomes, where is equation 3? See here, not on this page, here it is. Y is equal to r sin omega t plus theta. So we'll substitute here r value. What we are getting? Phi is equal to 2a naught cos phi by 2 into sine of omega t plus theta, right? Now we can keep this in bracket. This is what resultant displacement we can say. Now we know intensity is direct proportional to square of amplitude. What I said, intensity is direct proportional to square of amplitude. So therefore if I want I0 individual intensity, then it is direct proportional to A0 square, amplitude of first wave, or amplitude only. And if I want resultant intensity, then it is direct proportional to R square, right? What is that? R square. So what is R square here? R is resultant amplitude. R is what? Resultant amplitude. Resultant amplitude. So therefore, I is direct proportional to R square value we know 4 A naught square cos square phi by 2. Yes. If suppose proportionality constant is 1, then is A naught, hai na? We'll keep here A naught. So then I is equal to 4 A naught square cos square phi by 2. So intensity I can write like this 4 into I naught, because at the place of amplitude square I can substitute intensity. So cos square phi by 2, and therefore I is equal to 4 I naught cos square phi by 2 is what your intensity is. Right? Note down. So from this analytical treatment, what we found? We found that the resultant intensity of wave, when two waves are of same amplitude, are reaching point P. Okay. So next, now note point. Note point. If amplitudes are different, if amplitudes are different, amplitudes are different means, suppose we are having first wave displacement y1 is equal to a0 sine omega t, and another wave displacement y2 is equal to, let us suppose something b0, because its amplitude is different now. b0 its amplitude is b0 sine omega t plus phi. Then here r is what resultant amplitude, r is equal to under root of a naught square plus b naught square plus 2 a naught b naught cos of phi. Yes, yes or not? And suppose now in this case only, if you want intensity, yes, what we want intensity, then here I is proportional to r square, I naught is proportional to a naught square, or I1 we will keep. Okay, but we will keep here instead of I naught, I1 I will keep, because we have another one also, that is B naught, then we cannot keep I naught 2 or something. So better I will keep here I1. So I1 is proportional to a naught square. This is I2, which is proportional to B naught square. And if I want this I, then this I, if I want to write, then I will write like this. I is proportional to R square. So A naught square plus B naught square plus 2 A naught B naught cos of phi, that is equal to, this is I1 plus I2, keep here B naught. Okay. I1 I2 plus 2 root I1 root I2 cos of phi. This is what your intensity I is in this case. Okay, right? Next, let's move ahead. Now this was what note point, but we got I is equal to 4 I naught cos phi by 2. This is now note point finished. So next is continuation part. So see here, we got we got I is equal to I naught, that is 4 I naught, है ना, 4 I naught cos square 5 by 2. I is equal to what? 4 I naught cos square 5 by 2. So maximum intensity will be when I maximum is equal to 4 I naught when cos square 5 by 2 must be equal to plus or minus 1. I max is equal to 4 I naught if cos square 5 by 2 is equal to plus or minus 1. Yes or not? So let's move ahead. So cos square 5 by 2 should be equal to plus or minus 1. That implies 5 by 2 should be equal to 0, comma pi, comma 2 pi, 3 pi, and so on. So if I will transfer this to here, then that implies pi is equal to 0, comma 2 pi, comma 4 pi, comma 6 pi, and so on. That is pi must be equal to n is equal n pi, where n is equal to what? 0, 1, 2, 3, and so on. Right? Then what is path difference? Path difference is equal to what? Path difference should be x is equal to n lambda, where n is again 0, 1, 2, 3, and all. Okay. Next one. Conditions for destructive interference, that is I minimum. Yes. So here this is I am writing here like this. Condition for that is I maximum. Next, path difference finished, and now again conditions for destructive interference. Constructive finished, now destructive. In constructive you will get maximum intensity, in destructive you will get minimum intensity. Conditions for destructive interference. So in this case what I should be? Minimum, that is intensity should be minimum. तो इंटेंसिटी क्या होनी चाहिए? 0. Yes or not? So when it is possible, if cos square 5 by 2 is going to be 0. So for what values you are getting this? So 5 by 2 should be equal to 5 by 2, that is 90 degree, है ना? Cos 90 is 0, comma 3 pi by 2, all 3 pi by 2, next is 5 pi by 2, and so on. So you should get phi is equal to what now? If we will multiply that side, so this will become pi, next is 3 pi, next is 5 pi, and so on. So here you are getting phi is equal to 2n minus 1 into pi, where n is equal to what? N is equal to 0. No, 0 is not possible. We will keep 1. 0 means minus you are getting. It should not be minus. Okay, so we take 1 only, direct from 1 to 3. So n is equal to 1 comma 2 comma 3 and so on. So here path difference is how much then? In this case you are getting path difference x is equal to 2n minus 1 into lambda by 2. 2n minus 1 lambda by 2. So note point again here also. What are the note points? See, I maximum in case of this finished here only. Okay, this is the new note point for you. I maximum by I minimum is equal to or directly proportional to a naught plus b naught whole square divided by a naught minus b naught square whole square. Even you can keep equal also, but we will keep here equal to. So indirectly I maximum is directly proportional to a naught plus b naught square, and I minimum is directly proportional to a naught minus b naught square. This one is important. W1 by W2 is equal to I1 by I2, which is equal to a naught square by b naught square. What is this W1? W1 comma W2 are split width. So when you are solving problem, these formulas are very useful for you. Okay. So we will stop here for today. Note down these points carefully and try to understand intensity and amplitude relation from this analytical treatment. Amplitude and intensity. That's it. Nobody will ask you to derive the derivation total, but just how you are getting amplitude and intensity, that is what important to learn from this. Okay, so let's stop here for today.